Okay, just quickly flipping through this chapter and trying to get an idea of what we're doing again. But I'm pretty sure that it's essentially just proving the monad laws. So we're gonna try and do this with Hedgehog because I want to learn. So what we need really is two things. We're gonna need Hedgehog, and I think we need this. Yeah, I think it's supposed to be like checkers, but I think it's supposed to be like checkers, but I don't, we're gonna have to find out. Oops. Okay, so stack new chapter 5. What do we use? 1330 is what we're on for I think it's 1330. 865 is currently 1330. We need to put something in here, which is basically interlude. And then we need to do our classic fix these two files, and then we're done. Because there's actually going to be nothing in either of these files, I suppose. So I don't think we're going to have I don't think we're gonna have anything in lib. We're just gonna use the test in this case because really we want to just use this hedgehog thing to try and figure this out. And I've never used it before, so I think it could be interesting. So first thing we're gonna need to do is build those things. So let's just do that. 23g dash hedgehog classes. I think that's right. Yeah, so let's start here. And what we'll do is we'll quickly try these things. Go from there. You prefer to I think we'll avoid template Haskell for now because I've never used it before. So we'll just use something like this to test our property. So let's do that. Stack build. Extra adapts 42 GB. Do okay. Hopefully this won't take very long. Doesn't look like it. We got a pretty powerful computer, so it's helpful. The specs are below if you're, for whatever reason, interested in it. I didn't build this one myself. I was too lazy. Normally I build my own computers, but become lazier and lazier as I'm getting older. Let's see if Moobot's lying to me. Oop. The last few times have been pretty quiet chat-wise in the beginning of the stream for whatever reason. People are busy, I guess. Okay, so we're going to use these things. Oh, they're here. I'm gonna change this to overloaded strings. Ay, excuse me. And then we're gonna have our main function. Let me put this over here, like easier to read. Our main function is just going to be this. Oh boy, happened. Okay, and then we need this property. And guess that's it. We'll leave this open though. Yeah, so this returns a bool. So some sort of result. Nope, not print. Void reverse. Okay, but that's what we're testing, so let's leave it there. And then we need to format this. Okay, so how does this look different than quick check? Because so we see this gen list thing. We have a for all here, which must come from Hedgehog. And we build a linear list where we generate, I don't know what gen.alpha means here. Does anyone know what gen.alpha means? We can go look, I'm sure. Alpha. Generate an ASCII letter. Wonderful. Okay, so this is generating a list of 100 characters, and then making sure that reverse applied twice gives you back the list. I don't really know what this for all is doing, so let's go look at that. So that's in gen. And I think, nope, in regular old Hedgehog, we should get, oh, this is kind of useful. Oh, not really. For all should be in here, I think. Generates a random input. So it takes a gen and returns a property t within a monad of A. Okay, interesting. So run this. So we don't actually care about the return type. How do I throw away? Is there a check parallel underscore? Doesn't look like there's. It would be nice if there's a check parallel underscore, but I think I can get rid of this with void. Let's see. Google void. Yes, a functor of A to functor there. So we can just. We don't really care about this, I don't think. We can probably just do void. Where's void come from? Control monad. Okay. So that just gets rid of that boolean because we don't actually care about it, and then we can just run stack test and we should get this thing. Okay. So now what? Now we need to try a simple one of these, I guess. Do. Do. So generic semi-ring, ring, storable, applicative, comonad, foldable. Okay. So we want to test monad laws. This looks pretty intense. So how do we do this? Generate a small set int. Generate a small map string int. I suppose we can just do it from a list, right? What's going on, Oren? How are you? We're trying to learn a little bit about Hedgehog. I don't know if you've ever used Hedgehog. And of course, it's really loud out there. Hang on. Bring this over here because I have a question for you. Starting capture. Chapter. It's chapter 5 actually. We finished chapter 4 last week. Chapter 4 was the which one was it? I think it was the utilities one. Yeah, utilities for monadic code. That one's not on YouTube yet though. Okay, so really what we need is just a list of, I don't know, numbers, I guess, something. So we need like, I don't know, a gen list, which is going to be a gen and then we need to go. You missed chapter 4 or 5 or the 4. I said it right the first time. It's possible. It was kind of like a utility thing, and we've kind of done it before, so I'm sure you're actually already familiar with it. No, it's not related to this chapter really. The next chapters are going to be built upon the stuff we've done. So like this one is called like an interlude chapter, and I think we're chapter 6 is where things are going to start getting really interesting. So I'm pretty excited about that actually. So I need Hedgehog gen, and I want to generate some numbers. Do I care about integral? Probably just int, right? Newmaid, resubscribing for 2 months. You're insane, and I appreciate you. Also, hello. I know you don't get to watch the stream very often, so I'm happy to see you. I mean, let's just make some integers, but I need to figure out what this range object shit is. I'm doing very well. How are you? So, gen int takes a range int. So I need to give a range. Enjoying my country. Wonderful. What are you going to see? Anything in particular? It only takes an A? I'm confused. How do I generate one of these things? Range constant from? Range. visiting family and a wedding and more family. Well, that's really good. So I think your country in this context is the US. Um, yeah. Okay, so I think we just want range dot constant range. No, range. No, gen dot int range dot constant. Oh, list integer. Why did I write it that way? I mean, I know it works, but it's a weird way to write it. And this creates, can we create an integer? This is range, so I need to go back to gen. Can I not create an integer? Apparently not. So we will just create a regular in. Oh, Swarm Collective as well. My goodness. Everybody's showing up today. Wonderful. Happy to see all of you. We're gonna try and work through some of this. I don't really know what I'm doing yet, but hopefully it will start making sense. It's a little different than doing quick check, but not terribly different. Some of you may have done this already. Okay, so here what I'm doing is defining a random list from where the values can range from 0 to 100. Oh, we can look at quick check code as well. I can write quick check code as well if you want. I'll write it in a different file though, to compare and contrast if you want. It's not that hard to write this stuff because we're using standard data types. I don't plan on writing any custom data types. I just wanted to use this as a way to test all the laws and sort of, I know, like I've done this kind of chapter before, so I'd like to just, use this chapter to learn something new. So that's what I'm doing. Okay, so anyway, we're generating a random list. So that's what this is. So this is a linear range from 0 to 100 and make a list. And then generate integers for that list between 0 and 100 as well. So that's what we're going to do. I suppose we can probably look at this list by just... I'm not sure exactly how to do it. There's probably a function in here to extract the values that it actually generates. But that's what it looks like. So then we are going to comment this out because we don't really need it. It was just an example. And actually, let's put it up here and say... It's not A, it's sort of... It's like exactly the example in the documentation. So let's just write that. Okay, so there's that. And let's go look at this again. And then what we want to do is test... I think we need a list of laws. But we don't really need a list of laws, do we? That's for laws check many. We only need to check one. So it's gonna... Okay, cool. I can do that. So I think we're gonna have main. We probably don't need do even. We just need to use laws check one. our gen A is gen list, and then we need a list that contains monad laws. Oh gosh, that's clearly not what I wanted. But something like this. This returns a bool, so we need to stick a void in front of it. No, maybe we can't. Okay, I think we're gonna need. I need to fmap. I need to look at the type. Maybe it will make more sense. What I need to fmap. Oh, I see what you're saying. I need to fmap void. I see what you're saying. Um. And that I need to fmap it twice, I guess, is what that's implying, right? No, it's not. Let's go. Let's look at the uh here, let me do this real quick. Um um duh. I want to see the whole error. I'm having a hard time. And then I'll answer the rest of your questions. Oh. Uh does this not check the tests? How do I get GHCID to work with the tests? So you can see it. You can't see it down there. Do I need main is chapter 5 test? Oh, it's not. Oh, that's not it either. I thought it was main is or something. Because I can't do stack test here, right? Yeah, I didn't think so. Does anybody know how to do this? I mean, I can Google it real quick. So, GHCD ID on stack test. Oh, okay. Uh, let's try this. Sorry, I've never done this before. Okay, well, that doesn't work. So we want to do stack REPL -t colon bang. Okay. Oh. Why does it keep saying that? I don't understand what it's doing. I don't understand. Okay, let's go back. Can you explain what gen list is doing again? Yes. So gen list is basically the way need to run main not test. Oh, wait, isn't that what this is? The main is in my test file though. Right, this main is in test spec hs. Is my command still just stack repl? Because that seems like GHCI needs :L load to load the file. Oh, okay, that's fine. That's totally fine because I don't know what I'm doing. Um, let's see if we can find some more. We want to check out this post. Matt Parsons. Thanks, Matt Parsons. Okay, so we need to say stack GHCI, the lib, and then test, probably. GHCI chapter 5 lib, chapter 5 est, t main. Okay. Sure. We'll use what he used. Wait, went back here. I'm very confused. Let's just run it like this. Okay. So expected type gen list int to laws actual type. Ugh. Couldn't match type. Gen T data functor identity with. Okay, let's go back a little bit. So the way I understand gen list, although now I'm a little concerned because I have two gens in here. But it seems to compile. So anyway, so gen int, this piece here. Oh, I can't get rid of that. That piece there, I can make this a little bigger though. Hang on. Oh gosh. Okay. So this bit here is supposed to make a random integer, and this is supposed to make a list of those. Although potentially we're just getting one list, which is entirely possible. I'm not 100% sure though. This didn't work, unfortunately. I'm being rated. Seek a player is rating with a party of 10. Seek a player. Thank you very much. I'm not with 18 chatters. Wonderful. So, hey everybody. My name's Barry. We're trying to learn how to do something in Haskell. I don't know who Seek a player is, but now I want to check. What do you work on, Seek? I'm a nobody. So am I. Hi. Oh, you're learning React. That's really cool. Another functional driven thing. So that's cool. Thank you for the raid. Really appreciate it. I am also a nobody and generally don't know what I'm doing most of the time. So maybe we would maybe we have the same problem. What was I doing? I'm gonna go with acids. Thank you so much for the follow. Oh, speaking of which, somebody else followed while we were gone that I forgot to shout out. So they're probably not here, but I'm gonna shout them out anyway. Former 1923. So thanks a ton. I did forget what I was doing though. Oh, thanks, New Maid. New Maid's wonderful. We need to figure out what this thing is doing. That's what we need to figure out first, because this this looks like the code that they've given us. Let me bring it back up. So we're trying to emulate essentially this code right here, but it doesn't work. Oh, we could try it from the command line as well. That might help. Let's try that first and see if it works. Maybe it's just because we can't do this in main. Let's find out. Stack REPL. Load test spec. Fine. So now we should have this. Oh wait, apparently not fine. Right. Oh my gosh. We can just comment this whole thing out. Okay, so now we have this gen list thing, which I assume won't run because I need to somehow evaluate it. So we need like a, I don't know what it's called here. We need a gen A to A sample. So this is what I'm trying to do. Maybe print would work as well. Sample gen list. I do mean that. Well, there's nothing in it. It seems problematic. Well, maybe, but I still have this gen thing in here. I meant print. I don't think that's gonna work. But I, you know, anyway, this, wait, there's something in it this time. Did I just get really unlucky? That's hilarious. Yeah, I don't think it can have an instance of show, right? Because it's by definition an object that generates randomness. So that's what it's doing. It's just generating integers for us. So, oh, for the folks from Sika Player stream, if you've never done Haskell, let me explain a little bit about what's going on here. Because this is probably voodoo magic right now, or you don't really see where we're going. One of the cool things about this Hedgehog, or there's another one called Quick Check. The cool thing is that you can check these laws like automatically. So if you know what these monad laws are, let me find them for you. Hang on, monad laws. So we know that these are the monad laws. Okay, so I should probably also explain that this is coming from a book. So I'm reading a book, Book of Monads, and basically trying to learn about monads and Haskell through it. So this particular chapter is all about proving laws of the monads. But I've already done that before in another book. So what I'm trying to do today is basically learn Hedgehog specifically, which I've never used before, to prove the monad laws for particular monads, in this case, list. So anyway, we know now that we have a gen list that appears to be working. So let's try this on the command line and see what happens. And half of those people dropped. They're not into this, guys. They're not into this, and that's fine. I don't blame them. This is very weird. I'm not trying to be popular, that's for sure. Okay, so that's that, and then we want to run this. So gen list monad log. Actual type. Okay, that's what I thought we were doing. So I don't know why it's not working. Functions that take a generator and output laws. So I would have guessed that that's what monad laws was. But it takes this. Okay, NewMade said something, so let's read it. Gen int gets a random int, and then gen list generates a list of ints using that int as its length. Oh, maybe that's correct. No, I don't think that's correct, because I don't think that's correct, because I think this bit is the piece that's saying, and we can prove it by doing this. So this bit is generating a random integer, and this bit is defining a list with length 0 to 100. So you can only have a maximum of 100 elements in the list. So if I changed this, it should change the values inside the list itself. And let's just prove it to ourselves real quick, because I'm actually not completely sure as well. So we need sample. Nope. G dot sample gen list. Yeah, see. So it's giving us a random list with a length 0 to 100 and values 0 to 1,000. And each time it samples a new value. Did I finish explaining why we're doing this? I don't remember. Yeah, maybe I didn't, but hopefully you see where we're going. The idea is to prove properties. So you could prove, for example, that applying reverse twice gives you back the same list. So that's an example property. But right now we're trying to prove laws. But I don't understand what's going on here. I wish there was a monad laws example. Because I don't understand what it needs. I could look it up, I suppose. Good question. I actually don't know. It's gotta be in here, I would guess. Laws. Oh, I can just click this. It has a type class with a string in it, apparently, and properties that map string to properties, essentially. This is a pretty big thing. Library. Okay, let's look this up. Hedgehog classes monad laws example. That's the not gonna help us. Some cute hedgehogs. Just for reference, hedgehogs are pretty hard to take care of if you ever want a hedgehog. Let's see if it's in here. I suppose we could. That's actually a good idea. We could probably just create them. But I don't know how to create the laws. That's the key. Well, I mean, I guess we could just write properties, right? That just do this for random monads. So I guess we don't even need. You're right. Maybe we don't need to do this. Maybe we should create our own laws or properties rather. That's probably a better way to do it. Let's try that. Let's see if we can do that. Go away. Okay, I'm gonna get rid of this. Yeah. So let's create a few monads. I like where your head's at. So let's make a maybe int. I like where your head's at. I'm a little confused why that doesn't work, but I don't really feel bad about that. So we need to somehow make a maybe. Returns a maybe generator until it produces a just. Cool. Generates a nothing some of the time. That's exactly what I want. So I want to gen dot maybe. How do I need to give it monad of A. So I need a Need somehow to create this. Okay. So that's what I was thinking. But it needs to take a monad of A, not. Oh wait, no, that's a monad gen. So yeah, maybe that's all you need. Hang on. Let me look at the type of int again. Well, there's gonna be too many ints. Yes, it just creates a monad gen of A. So yes, that's all we need. You're right. I'm overthinking. My bad. Mobby. So that would give us a maybe integer, and who wants to shoot out is not the best proof, but it will help understand. I agree with that. Um, anyone want to shoot out another monad we want to try? Trying to think of another easy one. I mean, these are easy. I suppose we could just use identity, but like that's kind of a stupid one. We could do either. Let's see if there's an either. There's no either. Um, non-empty list, a set. We could make a map or a set or something. Our is a set a monad? I'm not sure. I mean, I guess so. Wait, no, that doesn't. Here, we can go look. Much easier to do it this way. No. Map? No. Okay, so let's just leave it at that. I'm fine with that. Um, much easier to do it this way. I don't really feel like learning how to. I mean, we could, but I'm not sure I want to learn how to generate these gen instances right now. It's very annoying in Quick Check, so not that annoying, but it's a little annoying. You know, we can do it. We can do it. So we're gonna take either string int and either string int maybe we can do it. Can we just like wrap? So if this type checks, then we can just do it. Okay, so that type checks, which means what I need to do is either I just said. So there used to be like a one of generator thing. I don't know. Choice list of monad A. So that would work. So we can do gen dot choice. Is it a? It's a list, right? Yeah. Of right gen dot int or left gen dot string. Nice. Okay, there you go. We did it. I knew I could figure it out. It's just being a punk, I guess. Okay, so the next thing is we're gonna do, yeah, we can do left identity. So for that, we need a property which is going to take a monad of M. Whoops, sorry. Needs to be a property. No, it does need to take a monad, so it does need it does need input. Yeah, that's probably a good idea to start just with maybe. So we're gonna, but really it can be generic, right? We really just need a monad M of A to property, right? I think. And then I have it sitting here. How do I generate a random function though? I don't know how to do that. Shoot. Um, I guess we just have to choose a function. Probably. So function is going to take a gen. How do I? Oh no, I would just do. We basically just need functions that generate that make ints into ints, right? Uh, no, because some of them have to work on lists. It's got to be. They need functions that work on a monad of int to monad of int. Maybe we can just find some. Right, they need to look like this. If they don't look like this, then they won't work for like lists. Because we need functions that can potentially change the shape of the list. Otherwise, it won't work. Right? Am I thinking about this correctly? Is it, that could be right. That is right. Oh, you know why this is confusing? I'm looking at the wrong thing. That's better. Yes. And I mean, the thing is it doesn't really need to be another integer, but that's gonna be a lot easier. So can we find functions like that? Reverse channels doesn't really help us. Here doesn't really help us. Well, kind of does. I mean, we could use, you know, +1 fmap pure or something, but that doesn't help us. Can't change the. Okay. I think we need to remove the possibility of this being generic, just to make it easier. So what can we do? Sure, we can add 1. We could just take it and return nothing. That's kind of an annoying thing to do, right? What else do we want to do? I mean, it kind of covers really 2 cases that would at least do something. Let's get this one working first. All right, so first things first, we gotta go get 1. So we're gonna say maybe X. I forget what for all does already. I should leave this open actually. Isn't this a link? Do 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 do. Okay. Yep. So that's what that does. So we need for all, and then we are going to say gen just function. And then we want to apply that to a gen maybe int. And then we want to say Wait, no, no, no. That's what we want to say. And then FMA is huh? If we can make this more generic, we'll do it afterwards. But why? What's going on here? Fine. Um. Right. So we don't actually need our function creates a maybe int. Yeah. This is wrong. This should just be like x, and this should say gen dot int, and then x. Why does it need show? Who cares? Why is all this failing? Oh, well, I know why this is failing. These need these. Oh, let's do this. What am I doing? Give me a second. It'll make more sense here in a little bit. I'll get there. But I'm having a hard time explaining what I'm doing right now because this isn't quite right. As you can see, we got a bunch of failures. We need a range. No, wait, what? Oh, okay. Needs that and gen.elf. Oh, that needs to be a range. It's a range. It's back to 100. Okay, let me read here. No, I don't need the either, but I'm just fixing these one by one. I mean, that's the answer, right? I mean, that's the left identity law, right? Fx equals return xf. It's definitely a weird thing to write, but yeah. Okay. Oren wrote it for us. Oh, I need to wrap these in gens. These can just be pure. Okay. There's that. And then, so can everyone see where we're going right now anyway? I understand that I had to write a bunch of stuff there to get us where we are. But, you know, I'm just trying to write less stuff. So, you know, yes, we didn't need this right now, but we do kind of want it for our type checking. The only thing that we have left is that there's no show for this arbitrary type, so we'll just write one because we don't really care. There's something I need to enable to make this happen. Pure is just gen, right? It just wrapping it in a gen data constructor. So if you look at this, right, I need to fmap right into this because this gen it is a gen int. Yeah. So if I don't have a gen of this function, I can't even gen choice it and return that back. So that's what that pure is for. I need to turn something on for this. I just don't remember what it is. Flexible instances. I should probably know that by now. I think we've run into that a few times, but you know, I'm not very good at Haskell yet. Um, oh, right. This can just be const. But something's broken. I love when HLint does this for us. HLint's like, oh, left identity law, just do that. And it's like, well, seriously, that's not what I'm trying to do right now. I'm trying to prove it. HLint is so smart. Although I don't understand what this is complaining about. Do you see what I'm not sure. Anyway, I think this is it, right? For the left identity law? Uh, just that. Because it knows. It knows that's what we're writing. We're just writing f of x. Is this... These aren't even necessary, right? Yes, they are. Okay, we're gonna try this. That's 100 tests. Cool. Assuming we're doing this right, I'm not 100% sure, to be honest with you. Time to take a drink. Let's do it. So it's pretty awesome that we got a raid today. I think that's the first time we've been raided. Oh, I was like, what are you saying, new maid? I agree. HLint is a she. Only a lady would make such nice design choices. Okay, neat. Now, the question becomes, do we think that there's any way... There's no way we can make this general, right? Like, this just function is really problematic for us, yes? Because there's no way I can write sort of generic functions as far as I know. There is a way to do this in quick check, but I just don't know if it can be done in Hedgehog, and I don't really know where to look, because if it's not in gen, I'm not sure how one creates functions. I don't know how quick check makes functions. Maybe the only reason it makes functions is because it's been around for a while. If anyone knows the answer to this question, I would, gladly. I mean, we can just try and Google it real quick. So, can Hedgehog create functions Haskell? You can make it generic for every monad. This was in 2017. Yeah, so I remember doing these co-arbitrary things. Yeah, I should just finish it. Hey, Fireball. At this point, I mean, Yes, that might actually help. Oh, hey, while we got a bunch of people here, let me ask you a question. So we have some emotes like such uh and other things. But we were talking in the Discord about having like a mascot for the stream, and I honestly think that the best mascot is just Hodor, the golden squirrel. Um, what do you guys think about having Hodor, the golden squirrel, as the mascot for the stream? Give him a little spin. He's just a doorstop. He's gold. Found it at the store. I thought it was hilarious. So I was thinking that maybe we change to that as the sort of stream representative, and put that next to all your names instead of other things. Yeah, I agree with that. I was just thinking is the idea. He for sure practices Piffsoft. For sure. And by the way, uh, where is it? There we go. If you have never heard Piffsoft, there's Piffsoft. Okay, so Hodor the golden squirrel, who all he cares about. So yeah, okay. So that'll be the joke, right? Hodor will come over and we'll start writing point-free functions. That's a pretty good joke, right? And unless we have Hodor, then we won't write point-free functions. Something like that. I don't know. I can put him over my shoulder as well. There's also a rabbit up there, but there we go. Alrighty, thank you for lurking. All right, so that's going to be the thing. It's Hodor the golden squirrel, who forces us to write point-free functions. That's the purpose of Hodor the golden squirrel. Okay. But so active sent me a lead for an artist, so I'm considering purchasing art, well, digital art, I guess, so that we can have a a cooler stream or something. Yeah, writing point free to save the planet, says uh Hodor. I love it. Okay. And then, things like we can make little squeaks when people come and I don't know, raid and whatever else, little noises like chittering noises or something. It would be very silly. Okay, so the right identity is, where is it? It's just M. So we do need a monad this time. So we don't need an F this time. We need a monad of X. Let's use X because we were doing that before. And for all gen maybe int. And then we want to say mx is equal to redundant $sign, I agree. And I probably need to put this in parentheses. I don't know what this bug they're talking about is. Yeah, I do know that. Doesn't it sometimes compile to less efficient code as well? Isn't that a thing? I mean, I guess by definition, if it can compile to more efficient code, it can compile to less efficient code. Although I don't know that is by definition. Nope, that's not what I wanted to do. Okay, there's our next property. So for this one, what do we need? I need 2 functions, so I think that I need to write some more functions here because we don't really want to be returning nothing all that often. So what we could do is wait. There's a frequency one where you add a wait to it. So you could say, look, give me 2 functions that add more often or something. But we could also just put in some other functions in here. Also, can't I just do... what else do you guys want to do? What else can we do to an x? There's really not a lot that you can do to an integer, huh? Could take its... Google, give me some motivation. Well, that's... You don't have any motivation? I don't really have any. Log? I also don't want to, include another library for no reason. Probably would be better if I wrote, what, integral? I'm very good at what I'm trying to do, I suppose. What's the... That would be num. So what about num a to a? Gate. Oh, we could take an absolute value. That could work. Although we're not generating any negative functions, but we could. So Avoid lambda. I mean, I guess I don't need a lambda in any of these cases, do I? I can just do just dot plus 1 or something. Sorry. The associativity gives the ability to bind from inside the function, which then gives us lexical scoping. Could you define lexical scoping? This one does need a lambda. Right, I don't think I can duplicate the multiplication. That's minus 100, minus 10. How do I get? How do I generate the the section minus 10? MA versus you can access X. Oh, I see what you're saying. Okay, I got you. I got you. Um, we'll just leave the lambda. It's fine. I don't really care. Okay. So now we need two functions. So we're gonna have an f. Let's copy this line. I don't need to. And a g. And then I don't really want to use do notation. And then I also need the monad, right? So mx Why do I keep doing that? I did it again. Subtract. Thank you. G. And parentheses. Oh, it's mx. Use Kleisli. Fine. Look at you. Hang on. Odor bows. You. Yeah, that's fun. That's really fun. So yeah, I think that's what we're gonna do. It's great. Saving the planet. Saving the planet one piss off at a time. I mean, I want to learn this stuff, so I actually like doing this. Where do we get joined though? And then this is just dot. I think we're already using control monad. Yeah, we need it for void, so that's probably enough functions that, you know, if we did it 100 times, we're gonna get 2 different functions. Then we just have a bunch of H-lint stuff. But we don't want to use the Clydesdale arrow. We want to write it more explicitly. So, fine. And then all we need to do is add that one, and then we'll test, right? Yep. Prop just... Oh, wait. Okay, and then I guess we just try this, right? Seems okay. Ow. So the other thing I'd like to do is... So really, what's the only thing that changes here? These gen just functions, right? The rest of the properties will be exactly the same. So what if we take a gen A to MA, and that way we can just get rid of these. So I could say prop left identity and then gen just function. That way I only have to write the next functions for the other monads, and we don't have to rewrite these functions each time. How do we feel about that? It seems like a good choice. I think we can write it because I think it's just maximum reusability. I think it's just this. Where does that come from? Oh yeah, that's fine. So we can generalize the properties via the following. So we're basically going to generate, we're going to take a gen of int to m int. Now when we have a list though, that's problematic, right? Because it needs to take a list of int and generate list of int. So this needs to really be a. I prefer this capitalized, but I don't know. This is weird notation, right? Because of this prop. Wait, did I define this twice? The problem that you have to define it with return. Problem. Oh. I just realized what's going on. Ah. So the left identity also has to take something that returns an X. I need to take another generator of A in this case. This would have to take a gen A. Oh. The getting a little unwieldy. I'm fine with the join. I think that, I mean, it seems like a cool function to me. So I kind of want to put it in there just so I have to look it up later. But I think this is the right property for left identity. It's a little unwieldy, um, but technically generic, albeit pretty hard to read. So you would define it such as the following. It'd be like left identity general, and then this is going to get applied to our gen just function and a, what does it need to take? A gen integer. So, I mean, that's kind of neat. I'm not sure that, I mean, that does reduce quite a bit of code, I suppose. Um, because, you know, if I had to write these each time, that would be quite a bit of work. But this is pretty hard to read, I would say. But I guess GHCI did the lifting for us. It's not like I had to write a lot. So what time is it? 9:18. Okay, so I have to get off on time. So here's what we're going to do. We're going to write the generic instances of right identity and associativity. We're going to try to. And then we might stop, and then next week we'll quickly, well, let's see how far I get. So, well, grab this. Okay, so monad m, probably gonna need more stuff, so let's just put it in parentheses now. We're gonna need a gen ma, and we need to produce a property. So this is gonna take a gen ma, and then we need show ma, okay, that one's pretty easy actually. I think this one's gonna be a little trickier. Maybe, I mean, that doesn't do what I want it to do, but that's fine. What I should have done is applied FA or something. Would have been faster. Okay, so we need 2 function generators. So it's gonna look like this one probably. And we need a function generator. So gen a ma, gen a ma, and a gen ma. Oh, I see it. Okay. It's a little more readable. And then we can rewrite. So what I'm going to do is I'm going to cut this out. What I need to know is how do I make multiple groups? That's really the question here. Do I just do check parallel and make like this? And then do okay. This takes I think it takes the function generator, gen just function, and gen int. Yes? Gen int, yes, because it's fx. This time we need, or the second time we just need a monad, so gen maybe int. And for the last one we need gen just function, and gen maybe int. None of these are the right function names. Yeah, this is probably a terrible name. It's really just the maybe monad laws still. I'm wondering if I need to make the groups different, but it's fine. So now all you need to do is make the generators to feed to these functions, and you can deal with this. But the only trick is or what? How is this not maybe? Well, I mean, these specifically are still maybe monad laws, right? These aren't general. These are general functions that can prove left and right identity for more than just maybe. But this particular group are, yeah, exactly. The generators are the specific part. But they're still maybe monad laws. I see what you're saying though, but I don't want to write general next to them. Like, I don't think that really makes a lot of sense. But doing it this way saves quite a bit of boilerplate because you only need to generate your functions, uh, that for each of these. All right, so let's see if what I did actually works. It seems so. Now, one thing that I don't like is that it seems to me, based on the name of check parallel, that I should be able to give this thing multiple groups and it should be able to do checking in parallel, right? Or is it checking these three in parallel? I'm not really sure what it's doing, but it seems to me like I should be able to give it a list of groups or something. So check parallel. No, it does not seem like I can. Um, it does not seem like I can do the thing that I was thinking I could do, but that's fine. Unless I put them all in one group, then I guess they're tested in parallel. But these things happen sequentially unless I tell them to, right? Like I could get both of these to launch concurrently in different threads or something, but let's not concern ourselves with that. We're not there yet. Okay, so now I have generators for both list and the either string int. So what I need to do is write functions for those things. And then I need to write show instances, so let's put them down here. And actually, I lied. Let's put them underneath all of this stuff because these are specific. Ugh. Put them here. So that was. So I need a gen list function, which is going to be gen list int to list int. Yes? Okay, so let's go find some list functions. This should be a lot easier. Maybe not. The tails function returns all segments of the argument, longest first. What does that even mean, actually? Oh, okay. So we had a list of integers. This only works with strings. How does Tails combine these things? Doesn't look like it has like a semi-group, or not semi-group, a monoid instance or something, so it can only work with strings, yes? Yeah, this isn't gonna work. Um, we could do repeat, not repeat. What is it? Sorry, I kind of have a headache. I'm losing my steam pretty quickly, unfortunately. Um, it's replicate. List int, list int. That would work. Uh, that is a long name. I'm gonna call you AMC, or how about Torch? You pick. Either way, hello. You just have a long name, and I'm not sure exactly how to pronounce it. Anyway, um, awesome. When were you watching the stream? I really appreciate that comment. That's very nice of you to say. About to do design. Okay, I'll do that after stream. Here, let me write your name down. But you should send me a DM about that, because that could be I could be interested in that. We've been thinking about that. So AMC Torch. Yeah, send me a DM on Twitch about that. I'll take a look at it. But thank you for that. Appreciate it. Okay. Are you a Haskeller? Repeat. Isn't repeat in infinite though? I think I need replicate. Where was I? Sorry, I lost my spot. Here. So we can write replicate m. I don't know. That's one, right? How else can we embed? What if we just took Uh, so here, this is an idea. Let me know what you think. Oh, so I don't need to write, I can just write replicate here. Where does replicate come from? Nice. Okay, so I was thinking, what if we did replicate 10? And here's another idea. Um, so we're gonna get a list. Is bang bang shorthand for replicate? I don't think so. Bang bang is the list. Why am I blanking on the term? I don't know what the right term is. The indexing operator. There we go. So it's like, yeah. No, that's okay. So 31. So what if we did like replicate 10 head as a function? It's like just take the head and then make a bunch of it. I suppose since we have this function, we can also do tail. Yeah, this is point free, right? So it's gonna take a parameter. It's gonna take just the list of ints and replicate it 10 times. So you're gonna get basically list of int with this thing embedded 10 times, right? These ones are not point free. Hopefully, maybe that clarifies it a little bit. Why is this one complaining? Oh, it's not tail, it's last. That's what I was thinking of anyway, but you could also do that one can be point free though. Easily anyway. So how are these point free? Nope, he got, yeah, Newmaid got it. But I wrote it before you. Well, no, you wrote it before me, but I didn't look at it before I wrote it. Does that make sense? Oh yeah, I could do that. That's a good point. Let's make a smaller one though, because I don't want to replicate like a 100 long list hundreds of times. So let's do gen small int. And then also if we do that, wait, we need to do that a little more. Okay, so if we do that, we have to be a little more clever about the way we do things, right? Because we first have to generate it. I mean, I guess we're in the do monad, or in the gen monad anyway, so it should be fine. We only have to change a little bit. So gen int And basically we're gonna copy this, right, small here, and then we're gonna generate a list from like 1, because, well, no, we do want it to be 0 occasionally. Can you do? I was like, what's the question mark for? Hang on. Let's just do 0 to 10. We do want empty lists sometimes. Or not, it, wait, is, yeah, that should be fine. Okay, so now we need, if we want to do that, we need a do. We don't need documentation, thank you. We need to get a, like a count from for all gen list, I guess. How do we do this? Because this is definitely not going to work. Oh, first of all, I wrote gen list and I meant gen small, but it's still not going to work. Okay, so gen small int will get us a, we need to use that to get us the gen, right? Let me do this first. I don't think I need for all either. By the way, I just wrote that because I thought that's what I was going to do. What I need to do is basically use gen small int to get me gen int. So I'm gonna write, and that will get me my int. How though? The functions have to change dramatically to make that happen, right? Because they need to take 10 as their first argument. Yeah, I think it does need to be bind. But can I do that? Maybe I can just do that. Because that's really all I need, right? So that's probably right. Yeah, it seems right. Well, it compiles. Where was I? Sorry. All right, so there's 4 functions. Maybe we should just put one in here that's just also like, well, no, this is probably fine. Do we want to do tail? We don't want to do tail. I'm a little concerned about tail or last because now it's going to actually fail. Like that, these can fail, right? If they're given empty lists, actually, if any of these will fail if they're given empty lists. The only thing that wouldn't fail is this, but it's not the kind of failure that we want. It's a error, right? We don't have a safe way to do this. So could potentially just yield to errors in Hedgehog. I doubt it is handling them for us. So these aren't great functions. It's the wrong kind of fail. So I think we want to avoid these functions actually and write functions that make more sense. Like what if we just did like those functions are not good functions. What if we just write this? Seriously can't do that. Oh, I need to throw away the argument. And then I probably don't need this. So const. Okay, can we think of other ones that's like a failure in the sense that it's creating an empty list, right? I can't create an infinite list, so I can't use like something else. So I think that's really all I can use. I can use replicate the thing you gave me or replicate with an empty list. Yes? I think those are the only options. Safe options. Let's use these. I mean, I need to get off, so I want to just test these and get off. Can we, I'm going to skip this, but I'll leave it here. I'll put a note here. Need to implement gen either function. Although I have a feeling that's going to be slightly even trickier, but maybe not. Okay. And then let's write our test real quick. Oh, well, this can just be so this one needs to be a gen list, and this needs to be a gen list function, gen list function, and gen list. Um, we could just put it here. As such, right? For now. Yeah, that's another thing is that's actually a good call. I'm gonna write that up here. We could probably do that next time, but that's not really the exercise for today, I suppose. But I agree that that's probably a good. Let's put the notes at the bottom. Let's see if this works. It should work. Yeah. So that's kind of neat. Hedgehog's kind of fun. I think this is probably a little weird. These are a little tricky, and they may have been, they're written for us, but we didn't know how to use them. So really there's some notes that we need to take here. So 106G. So idea from Count Oren. Use prop another idea from me. Use monad laws built into hedgehog.classes to test monads. So those are kind of the last two things we need to do. But I think that this is kind of working. Was this interesting? I don't know. It's kind of weird. We're a little familiar with these, so it's not that big of a deal, but I thought it was kind of an interesting thing to do. Instead of skipping this chapter, to do something with the chapter. But the next chapter, for example, is pure reader-writer state monads. And I think we're going to start really getting into the guts of the book. Like the rest of the book is all guts. And like important guts, not sort of building up to monads. So I think the rest of the book's going to be really exciting. So yeah, that's it for tonight. I went a little longer than I wanted to, but that's okay. Does anyone have any questions before we head out? I can't commit my code because I don't have my my key. I thought it was fun. It's different. Yeah, this was a little intense because I just didn't know what I was doing. But I think that we wrote some decent code. It's not the best code in the world, but it was some interesting stuff. We did some cool stuff with. We learned about this function. Where'd it go? This join function. Totally lost it. There it is. We learned about this join function. I was expecting it to be over here for whatever reason. I sort of forgot about this subtract function, but I could have found that one. So we did write some point free stuff.